Hi everyone, we're back with Professor Stephen Williams at Southern Technical College, and we're going to continue on with the review, but going into Chapter 4 in your book, which is Motor Control Devices.
Okay, I did a previous oversight of this material that I'd like to refer you back to. If we look at, when you go to your Canvas, I want you to always go in to modules, look for the day that you're working on, and find what's posted for that day. Typically, you'll have three things there. You'll have a lecture, an assignment, and a discussion. Okay? Today, you've got a lecture, an assignment, and a discussion. Well, I'd like you to go back to Monday's lecture, and in there you'll see some videos. Watch as much or as little as you want. I've taken you through the diagrams and the use of some of the symbols, okay, which you can see on the board here. And also I've taken videos explaining the different devices that are there. And those devices, I pulled them apart, showed you how they go together, show you how they get mounted. So here, what I'm going to do when it comes to this chapter, which is chapter 4, is I'm going to go through it very quickly, with the idea being tell you what is important and what is not, okay? As we flip through, again, I'm not going to try to reiterate what I've already told you in another place. So as we're going through toggle switches, you know, we've all seen the little toggle switches. We have different kinds there. Okay, it's important to understand single pole, single throw, double pole, single throw. Yes, that's important. Okay, the push button switches. I talked about them before. Again, important. Okay, the fact that you've got a push button station. Who cares? NEMA 1 enclosure, what is it? It's basically an indoor enclosure, right? You can see down here, indoor, no major hassles. Okay, if you're outdoor, you probably want to get into if you're only worried about rain, you got a 3R. If you're dealing with wind and maybe wash down with a hose, okay, you're dealing with NEMA 4. Explosion proof, blah, blah, blah. Okay, so again, these are the type of enclosures you have. It's dependent upon the environment you're in, right? Okay, so what I want you to know is the difference between normally open, normally closed. Here's a nameplate that you might have on a push button.
And this is a bezel. We saw that NC for normally closed and NO for normally open on a lot of those devices last time.
And that's going to be very typical. And again, it's always being shown shelf state. De-energized, sitting on a shelf the way you'd buy it. Okay? If it's something that it doesn't matter if it's on the shelf or not because you don't know which way it's going to be, then there typically be a little legend given where it'll tell you if this switch, for example, like when we get into selector switches, if it's in this position, you have two contacts. Contact 1 is open here and it's closed there. Or it's in the middle, it doesn't do anything. So again, shelf state, not energized, just the way it came out of the box, all right, is the way that the contacts are shown. So as we flip through there, pilot lights, again, they all come in different colors. Some of them are, the newest ones are LEDs. It cuts down the heat load. It keeps your changing of lamps to a minimum. The old ones that have been in there, they're just the incandescent ones. They don't use them very much. A selector switch is a rotary device, okay? And It has a cam on it that operates plungers, that as you turn it, it plunges and causes the contacts to change state. Okay, a drum switch. Drum switch is something that could be used to basically, if I have a reversing motor, for example, if I've got a three-phase motor, we talked about it before, if you want to change the direction of a three-phase motor, you simply change two of the three phases, okay? And the drum switch will do that for you, okay? So it eliminates the need for having a forward and reverse contactor. You can use this to change and use the same, I'd use a single contactor. To be honest with you, I've never seen one. I've never seen it used. They almost always use the two contactors. However, that's life. Okay. Now we're looking at mechanically operated switches. Okay. Limit switches being the most common. All right. So you're coming up, you're opening a garage door, it opens up, it comes all the way to the top, and it hits, a little roller arm hits on a top surface, click, it stops the motor. Okay, now you change directions and you tell it to go closed, and it's coming down, and now you reset the top limit. It's open again, or I'm sorry, it's closed again, and you're coming down, and you're coming down, and you hit the bottom, you hit a limit on the bottom, the roller clicks, and the motor stops, okay? Or if you've got the safety feature, it hits that photo cell that tells you, hey, you got your car in the middle of the door coming down, and blocks and tells you, stop the thing, take it up. All right, so you can see by the pictures there, there's a number of different varieties. The thing is, they're mechanically operated. Okay, now, part two, mechanically operated. Now they start getting into, I don't consider these, okay, when you start getting into temperature control devices, yeah, I guess you could say they're mechanically operated, but I like to think of them as process operated. In other words, I've got something out there that's changing a temperature, changing a pressure, changing a level, changing a flow, whatever the case may be. And as it changes, it hits a set point. That set point tells the switch to change states. Okay, now the temperature starts going back the other direction. It gets to a point where it says, okay, that's high enough. Changes states again. All right, resets. The time in between is a dead band. The time between the initial operation and the time that it resets itself is what they call a dead band. Okay, so yeah, do I care a whole lot that you understand the difference between one temperature switch and another type? No. Do I care that there's 100 different types of level switches? No. Do I care that there's 50 different type of flow switches? No. What I care about is that you understand that I have a symbol for limit switch, okay? That is a mechanically operated device. So a limit switch, it's got a little line with something that looks like a clicker on it. Think of it that. When it clicks, it changes state. Now, with a temperature switch.
Number 4.
With a temperature switch over here.
See the number 4?
Over here. Okay, with a temperature switch, you've got a squiggly line, okay? There's no better way to describe it, but to me, it always indicates temperature, okay? So when you see that squiggly line, it's a temperature switch. Do I care whether it's activated by a bellows device by a thermocouple that's feeding some other device? No. The fact is it's temperature related. It's operating on the basis of a change in temperature. Okay, that's operating on a basis of a change in position. All right, we move over to there. Now I've got pressure. Do I care how the pressure is measured? No. All right, the fact is you've got a symbol, okay, think of it as a little cup that if you blow into it, okay, it's going to fly away. Well, that's the idea with the pressure. If you fill up the cup with air, it's going to have a tendency to move, right? So I've got a cup, upside down cup.
It looks like a D, laying flat.
Yeah, I think of it as a cup. Don't worry about it. All right, and now I want you to recognize those symbols. Now, every one of these devices has some kind of device inside of it that's going to change the contact, all right? It has a set point. When it gets to that set point, okay, this shows, for example, a pressure switch that's going to open on a increase in pressure. This one shows, and it's going to close on a decrease in pressure. This one shows one that's going to close on an increase in pressure and open on a decrease in pressure. Okay, same thing over here, but now we're talking a level switch. Think of it as a little ball that's connected to your rod that floats if you got a sump. It floats in the water, and as it goes high, it'll close. Okay, as it goes low, it'll open. Stop pumping because the sump's empty. Start again because the sump's full. All right, there's 100 different kinds of level switches. Do I care that you know every one of them? Hell no. You may never see one. The fact that you understand that it's a level switch, that this over here is a flow switch. Do I care what kind of flow switch? No. It's measuring flow. Flow of what? Flow of a gas, flow of a liquid, flow of solids. It's flow. All right? So, again, keep it simple, stupid. All right? You got a ball, you got a little flag, it's flow. It's flapping in the wind, right? All right, so think of that as flow. It's the way I always think about it. Moving along here. Now, we're getting into sensors. Do I care? Typically, a sensor is something that you're not able to make contact with. All right, so you're looking, it's a non-touching type thing, and you're trying to see that something's passing by, that somebody's breaking a light. There's all different kinds. I don't care. Okay, you can, don't get me wrong, there's a lot of information here. I invite you to read through it. I just don't, I'm not going to test you on how a proximity switch works. I'm not going to test you on an ultrasonic switch, okay? There's all kinds of them here. Do you really need to know all that information when you may never even see one ever again? No. If you do, hey, you've heard about them. You know that they exist, okay? And you've got a book that you can refer back to. Chances are the technology is going to be changing, all right? And other things are going to come out. Believe me, when I started in this business, these things didn't even exist, all right? So tomorrow, you can bet that something else is going to come along. So with that in mind, don't get hung up on the individual
Components?
components and how they operate, because think of them as something that's counting. You know, I've got something that's counting gears here that I can tell, you know, once I do, how many gears do I got? 1, 2, 3, 4, 5, 6. All right, once I count 6, it's 1 RPM. Okay, could it be a tachometer? Okay, if I take the number of clicks for each one of pulses it puts out there, okay, then I can divide that by 6, come up with a speed. Okay, if I knew the the diameter of the gear. All right, so again, over here, you're looking at a level switch, all right, that's using ultrasonics. All right, cool, but it's a level switch, all right? Just cool. I'm not going to test you on it because I think it's counterproductive. All right, so what's that? It's a wind switch. So what is it? Flow, okay? Flow of wind. Here, temperature, okay? It could have a switch attached to it. All right, guess what? It's a temperature switch. I don't care. This happens to be probably a thermocouple. It could be an RTD. It could be any kind of different thing. You know what? I care that you know that you can use different processes to control how things work. All right, that's the key. Knowing how things work accordingly. Do I care if it's a thermistor? No. Resistive temperature device? No. I mean, these are quite common, but am I going to try to ask you about how all these things work? Nope, not going to. All kinds of flow meters, all kinds of different things, fine. Guy did a good job putting them all together. I just think it's an overflow of knowledge for you guys to try to get into. So with that in mind, keep just the basic simple things there. Keep it simple, okay?
The schematic symbols are always going to be important.
Yep.
Styles might not be.
All right, now let's talk about actuators. What is an actuator? Okay. Well, let's look at our diagram back here. All right, and let's look at the control portion of the diagram. This is all inputs. Okay, all the things over here are all inputs. It's telling something to start, something to stop. Okay? Something to go faster, something to go slower, whatever the case may be. Over here, along here, these are all outputs. All right? This has a coil. This has a light, an LED. This has an LED. This has a coil. That has a coil. Actuators, okay? The lights, I don't know that we consider that an actuator. It's more of an indication, all right? It's just telling you a status. It's not starting something in motion, so to speak, all right? When I energize this, yeah, I'm actuating that coil. I'm actuating this coil. I'm actuating that coil. Am I activating that light? Not really. So don't think of the lights as being actuators. So what else do I have? Well, over here, I've got a motor. Am I actuating that motor? Yeah. Okay, when I pull that coil in, that coil pulls these contacts together and sends electricity down to the motor. It's being actuated. All right, so those things are all actuators. Fuses, passive. Okay, they're just sitting there monitoring and shutting it off so something goes wrong. Breaker, same thing. All right, typically passive devices. They're in the system, they don't do anything. All right, now a selector switch, again, is a manually operated device. A transformer is a passive device. Is it being actuated on? No, no. Okay. Without it, things won't work properly, but you can say the same thing without the fuses. You can blow things up. So along here, actuators, think of it as something that you're acting upon, okay? That I'm closing a contact, that contact could be from a push button, a selector switch, a pressure switch, a limit switch, a flow switch, a temperature switch. It is something that's acting upon the actuator. The actuator is something that's being acted upon, all right? So let's look at what they're talking about here and flip back. I've got solenoid valves. Yeah, that's an actuator. All right. Now, what's happening? I've got a solenoid being pulled in, and in this case, it looks like it is, okay, I can only go by what I'm seeing. It looks like the spring force
Pushes it down.
is
makes a
pushing it down
connection.
because the coil is energized, and the spring, I don't see how it's working to push it back up again, but anyhow, there's a spring on there that's pushing it back in the other direction. I don't think they drew that very well. But again, you've got a coil that's going back and forth, okay? And one direction it's spring fed, the other direction it's coil fed, all right? Is it an actuator? Yes, it's an actuator, all right? Because it is being acted upon by the current, okay? Here I've got a coil, okay? That could be part of a solenoid. It could be part of a coil for a breaker, for a starter, a lot of different things. Okay, a relay, timer. All right, stepper motors. What's a stepper motor? Basically gives a pulse and takes a step. All right? That's basically all a stepper motor is. Very precise, takes a pulse in, takes a predetermined step of some kind. What's a servo? It's something that's using a closed loop system to provide feedback of where it's supposed to be versus where it is.
And that's that stepper.
So, closed loop, something that's it's going out there and doing something, and it's getting feedback on what it's supposed to be doing. Let's suppose it's supposed to be turning at a certain speed. It's getting feedback telling you that it's where it's supposed to be,
And that's on the closed loop one here.
or you're too low, or you're too high. So this gives you a good example here of what the servo does. And again, nice, but not terribly important. Okay. More types of actuators. You know, you got little motors, you servos, you got all kinds of different things. DC brushless servo. Okay, that's all well and good. All right, now we're to chapter 5, which we're not going to cover, okay, because that's going to be assigned for next week. All right, so along that line, I encourage you to go back, okay, on Thursday, let's say on Monday. I don't know if you've looked there, but under the lecture for Monday, I believe we put some videos in there, okay? On Tuesday, where we were covering, that was for chapter 3, where we were covering chapter 4, which is what we just got done talking about.
That's where we got hands on.
We put some hands on. That's where I drew this schematic that you see up on the drawing board here. Okay, and we also spent some time going through all the different types of control devices that we had available here, talking about them, showing you how they mount and how they work, pulling them apart. So you get something about it. The first part is I talked about and started from scratch in developing this schematic that you see here. Okay, so if you go through that, you'll see the
You'll see the
rationale
symbols.
for a ladder diagram. Okay, that was the whole purpose of it. And again, this is all stuff that I have here in the shop. When we did this previous time, we put this together into an actual starter. Okay. Unfortunately, easier said than done. It's kind of hard to come in and do hands-on when they won't let you in. Okay? So
But
the best I
hopefully
can do
soon.
is show you the junk that I got, and I will be going back and show you a little bit more of what I've got. So with that in mind, I put yesterday a couple of covering chapter 6. Chapter 6 is covering basically contactors and starters. And I went and pulled out some videos. I thought they were very well done, and I encourage you to go back there if you haven't seen them and take a look at them, give you a good overview. Again, don't get tied with the details, okay? I'm not going to be trying to trip you up. My idea here is to get you the knowledge that you need, and I'm only questioning you on things that I think you need. So I'm not going to flood you with stuff that you don't need, all right? So with that in mind, as far as review, do what we have here, and you can go back for the previous days, take a look. The midterm is 30 questions.
Good luck.
It's going to be available to you anytime. It's already posted, so it's available now. But
It
do
does
some
have a-
review. You only get one shot at the midterm, unfortunately. Okay, unlike the homework that we're giving you, you can go through it as many times as you want. But not the midterm, not the quizzes, not the final. Sorry, you get one shot. So spend as much time as you need. I believe the midterm is open till midnight tomorrow. Okay, so it's not just today, and if somebody gets locked out for some reason, please get a hold of me, okay? Because I can unlock it by snapping my fingers, or at least going on board and changing things in there.
With a couple keystrokes.
So it's easy, all right? My objective here is to get you through what I consider to be a trying period, okay? And the big problem I'm seeing is we're not in sync with one another. You need to go into modules every time. Go into modules, and it's going to tell you what I've got to store for you today, all right? If you want to move ahead, that's fine, but I'm not ahead of you getting prepared for it, so it doesn't do you a whole lot of it doesn't give you a whole lot of help getting ahead if I'm not there to guide you there. Now, you know that I'm going to cover, if you go in there now, you're going to see the modules that I'm going to be covering and when I'm going to be covering them. Unlike what was previously in there, it should reflect exactly what's there. Don't go to grades. There's still bullshit in grades that I can't get rid of. I will, but I can't get rid of it yet. So with that, good luck, guys. God bless you. Keep it up. Stick with it. I'm told next month going to be back in class.
Hopefully.
Hope. All right. Have a good night, guys.